Hey everybody, and welcome back to Math Woohoo! We are wrapping up with one of your final reviews for your Math 2 exam. So this review is going to cover triangle congruence, similarity, and midsegments, and it only makes up a tiny portion of that exam, but jumping right into these. So for the first ones, there are 5 different triangle congruence postulates. Side notes over here that if you see this little squiggle with an equal sign underneath, it means congruent. Congruent means same size, same shape. Other note to remind yourself that the only thing that you can add to a diagram is either a reflexive side, meaning if you have triangles and they share a side that kind of splits them down the middle, you can always mark that, or if you have angles that are vertically across from each other, those are like your kissing angles, you can mark those. Anything else, just because it looks like it, do not assume that it is unless it tells you. So if you look at this first one, it says you've got these 2 triangles here. What else can I mark in the picture? Well, I can mark these vertical angles. So then in one triangle, I'm going to have an angle, a side, and another angle. But this is not ASA because that side is not physically sandwiched between those 2 angles. So this is going to be AAS, or if you prefer or if you prefer, you can say SAA. But ABC, so following my pattern, notice that A has nothing in it, B has 2, then 1. So I need to follow the same pattern in the other triangle. A has nothing, D has nothing. B in the middle, so B has the 2 curves, B has the 2 curves in the other triangle, and C has 1 curve, E has 1 curve. In the middle, you can mark the reflexive. So if you look at one triangle, I have 2 sides and an angle. So then I need to determine, is this SAS or is it bad word backwards? In this case, it is ASS, but we call that HL if and only if it is in a right triangle. So following the same pattern, ABD, so down the 1 ticky, then down the side with 2, down 1 ticky, then the side with 2, so CBD. In the third diagram, I can also mark, and I'm going to use 3 tickies here because I've already used 1 and 2. So these are going to be congruent by side, side, side. ABC goes 2 tickies, then 1 ticky. So I need to follow the same pattern here. 2 tickies, then 1, so ADC. Given BD, this means perpendicular, and perpendicular means right angles. Running out of room. So where BD is this little line here, and I'm going to highlight it, meets AC. So where those 2 things meet, I am going to mark right angles. It then says that BD is going to bisect. Bisect means to cut in half. Angle ABC. ABC is this angle at the top, and I'm cutting it in half, so I'm going to put curves on either side. The last thing that you can mark is the reflexive in the middle. So this is going to be an angle, a side, and an angle, and the side is sandwiched between those 2 things, so ASA. Following my pattern here, ABD, so nothing, curve, right angle, nothing, curve, right angle, CBD again. And for this last one here, C is the midpoint of AE. So if I were to draw that, I could put a midpoint, boom, and it says it's the midpoint of AE. So because it's a midpoint, it's going to separate that into 2 different sections. Boom. It also tells me that AB is congruent to EB. So where AB is, I can put a ticky. Where EB is, I can put a ticky. The last thing I can mark is the reflexive side with 3. So this is also congruent by SSS. ABC, so 2 tickies, then 3. 2 tickies, then 3, so EBC. using the given information to prove the triangle's congruent. So again, the only thing that you can mark on these things is physically what they tell you, the reflexive and the vertical angles. So it tells you that CA is bisecting BAD, angle BAD. Well, I know, so I can start by filling that out, saying CA bisects BAD, and I can put G here. Why do I know it? It was given. So if I mark that, CA is cutting BAD, so B to A to D. That means this angle down here is being cut in half, which means I can put curves here and here. It also told you that B and D were congruent, so angle B congruent to angle D. Well, why do I know that? It was also given to me, and given is the reason D. I marked these angles in the picture, but I didn't put it in the proof yet. So I do need to write that out. So if I look in here, I could say I've got angles here where ACB. Well, ACB starts at A, goes to C, goes to B, so it's talking about this angle up here. Not what I want. I've got the angles BAC, so start at B, go to A, go to C. Hey, that is the angle I want, so that's going to be F. Why do I know that? It's the definition of a bisector, and that's going to be J. This should definitely say that AC is congruent to AC. Whoops. And my reason there should be reflexive. And then, so we're going to ticky mark there. ABC would be congruent to ADC. Why? And that's going to be you have two angles and a side. So I. Well, why, Miss Egloff? I have two angles here too. The side is not physically in between the two angles, so it can't be the S in the middle here. RJ is congruent to RS. So boom, boom. Why? What do I know? So RJ is congruent to RS. That's going to be a G there. It tells you L is the midpoint of JS. Why do I know it? Given. And again, because I have a midpoint, midpoint means that I can mark these two pieces congruent. So I'm looking for something that says like JL congruent to LS, which would be A. Why do I know that? It's the definition of a midpoint. RL is congruent to RL because it is a reflexive, which is going to be E. And JRL, so 1 and 3, would be congruent to SRL. Why? Because you have 3 sides marked. Sticking with this idea of congruence, so I also threw on this definition of CPCTC, which means corresponding parts of congruent triangles are congruent. So it told you lit was congruent to day. So I'm going to draw 2 triangles and label them lit and day. Just for space, I'm going to do it down here. I'm also going to increase the spacing here. Oh, let me copy that. So for lit, I like to start in the bottom left and then kind of go around. Same with day. And what do I know? It tells me that IL is negative 9x plus 6. IT is 150. AY is 10y minus 50. And AD is 132. And I asked you to solve for x and y. Well, notice that the pieces that are on the exact same spot, that means they have to be equal to each other. So then I can say negative 9x plus 6 equals 132. Well, hey, we have an equation, and anytime you have an equal sign, you can plug that in Desmos, y equals this, y equals that. Or if you prefer, you can solve it by hand. Desmos, y equals negative 9x, or what did we just say, plus 6. and y equals 132. Zoom, zoom, oh. Zoom, zoom, zoom. Okay, great. I'm going to find where they cross. So x is going to be equal to negative 14. Flip side to that. Is if I said 10y minus 50 equals 150. If you were to solve by hand, we would add the 50, divide by 10, or you could also say in Desmos, my caution to you is that you don't use two y's, so I'm going to change it to an x here and say 10x minus 50 and y equals 150. Find where they cross. Okay, great. 20. And again, Desmos. Two triangles again, Elf and Joy. And again, I like to label them starting in the bottom left corner, but that is just me. But whatever you do on one, please make sure you go in the same pattern on the other. It tells you E is 82 degrees. Y is 11x minus 1. L is 9x minus 1. Miss Egloff, why did you put these inside instead of outside? Reminder, angles are going to go on the inside of the triangles. And then I'm going to kind of do the same thing that you just did up here. I'm going to copy these pieces over. So Y is in the bottom left corner, which means it's going to be the same thing as F. So I can then say 11x minus 1 can go here. Well then, what do I know about angles in a triangle? Well, they all equal 180. So I can say 9x minus 1 plus 82 plus 11x minus 1 equals 180 degrees. And I'm going to opt to use Desmos to solve and say y equals this, y equals that. Y equals 9x minus 1 plus 82 plus 11x minus 1, and y equals 180. Okay, great. X is going to equal 5. But my caution to you is that is not what the question asked you to find. It asked you to find the measure of angle L. So I need to plug that 5 back in. 9 times 5 is 45, and 45 minus 1 is 44. Technically, that's degrees. So, and mid-segments. I think these are pretty easy so long as you remember a formula. And way back when on your test, what I saw a lot of is people wanted to say they were equal. They're not. The mid-segment, if you multiply it by 2, so if I take this thing and multiply it by 2, it is equal to the parallel base, but you have to multiply it. So AB is 7x minus 2, and DE is 3x plus 4. So I can say 2 times 3x plus 4 equals 7x minus 2. I'm also going to use Desmos to solve for this as well. So 2 times 3x plus 4 and 7x. Yep. Technically, you should be in the habit of having y equals in front, but it's not the end of the world if you don't, if you're using x's. But you're looking for where those two things graph. Okay, great, x equals 10. Where those two things intersect, sorry. It then asked you to find the length of AB. Well, AB is here, so I can say 7 times 10 minus 2. You can plug that in Desmos or hand, but 70 minus 2 is 68. Given DE is 3x minus 5 and 4x plus 6. Well, how do I know that this is a mid-segment? Well, since it splits this side, so both of these sides are congruent, and both of these pieces are congruent, I know that DE is a mid-segment. DE is 3x minus 5, and AC is 4x plus 6. So 2 times 3x minus 5 is equal to 4x plus 6. handy dandy Desmos again. 2 times 3x minus 5 and 4x plus 6. Again, you should be in practice that you have a y equals in front, but it's not the end of the world if you don't, if you're graphing with x's. 8. X equals 8. So then it asked me to find DE, so 3 times 8 is 24. 24 minus 5 is 19. And AC, so 4 times 8 is 32, and 32 plus 6 is 38. Ta-da! And then these last ones deal with similar figures. So similar figures meaning that they are the same shape, but not the same size. So it asks you to figure out a scale factor that would go from 1 to 2. Well, I can pretty easily tell that I can say 12 divided by 3 is 4. 24 divided by 3 is 8. So essentially what you're saying is 12 times some number equals 4. So if I divided by 12 divided by 12, k is equal to 4/12, which is equal to 1/3. 1/3 is the same thing as dividing by 3. So on this one, it's kind of the same thing. Actually, it is the same thing, but instead of being able to visually see like the 12 to the 4, this one requires a little bit more work. So I'm going to say 12 times some number equals 9. Divide by 12, divide by 12. So then k equals 9/12. And you can simplify that, divide by 3, so 3/4. And for these last ones, given RST is similar to RKJ. So if they're similar, there's a reason that they give you this similarity statement. I personally recommend, not require, but recommend, that you set up a proportion that uses small over big. What I mean by that is if you pick a side in the small triangle, so let's hypothetically say that I pick KR. KR is made up by the first 2 letters. So I'm going to say small side over big. So the big also needs to be made up by the first 2 letters of RS. RS is going to be 33. It's equal to, again, small side of the small triangle, so 2x minus 4. And that is made up by R and J, so first and last. First and last, so it needs to be made up by the side RT, which is going to be 66. There are a couple different ways that you could solve this depending on what you saw patterns wise, but I'm going to go ahead and do the way that works every single time, and I'm going to cross multiply. So I'm going to say 9 times 66 equals 33 times 2x minus 4. If you want, you can use Desmos or you can go by hand. We'll go by hand just because. 9 times 66 is 594. And 33, you got to distribute it, times 2, so that's going to be 66x. Minus 4 times 33 is 132. And then I'm going to add the 132 to the other side. $594 plus 132, $726 equals 66x. And then last but not least, divide each side by 66. And then so x is 11. And if you check back, that is what the problem asked you to find. For the last one here, this is probably the last one, or the hardest one that involves similar figures. And I again recommend that you do small over big. What I mean by that is the small triangle over the big triangle sides. So if I pick a side in the small triangle, so let's hypothetically say that I pick 7 first. So then I can say 7 over, it's not going to be 21 because that's not the whole side of that triangle. The whole side is going to be 21 plus 7, which is 28. Okay, and it's going to be equal to, again, the small side over the whole side, and that whole side is going to be an x plus 1 plus 27, and I can combine that and say x plus 28. How about 28, not 8? So we're going to do a little cross multiplication magic, and I'm going to say 7 times x plus 28 equals 28 times x plus 1. And I'm going to opt to use Desmos to solve this, just personal preference, but you are more than welcome to use by hand if you want. So 7 times x plus 28 and 28 times x plus 1. Ooh, come back. And I'm going to need to do a little zoomy. Make sure that you're finding where those two lines meet. So then we're going to say x equals 8. But again, pay attention to what this thing asks you for, because it asks me for ML. So if I know that x is 8, 8 plus 1 is 9, and 27 plus 9 is 36. And so I'm going to repeat that again. 8 plus 1 gives you 9, and 9 plus 27 gives you 36. Anywho, so that's all I have for you today, but in the meantime, happy studying for your upcoming exam, and I will see you guys soon. Bye!